In this video, we will be treating experimental techniques 1, the basics of experimental techniques in IGCSE, measuring equipment. Now, let's start with this. Name appropriate apparatus for the measurement of time, temperature, mass, and volume, including burettes, pipettes, and measuring cylinders. Once more, name appropriate apparatus for the measurement of time, temperature, mass, and volume, including burettes, pipettes, and measuring cylinders. Quite right. You know that in a chemical laboratory, a chemical science laboratory, there are some basic laboratory equipment that are used. Learners, it is obligatory for you to know the basic equipment in the basic equipment used for measuring in a chemical laboratory. So we will be starting with time. Time is an important factor that is used in the measurement of rate of chemical reaction in the laboratory. The speed at which a chemical reaction takes place, the factor that is very, very important there is time. And time can be measured using a stopwatch. Time can be measured using a stopwatch or a stop clock, which are usually accurate to 1 or 2 decimal places. You know, the units of time are normally seconds or minutes. But in some cases, like in a slow reaction, like in the process of roasting, we can use minutes. There are 2 types of equipment in this case. We have our stopwatch. This is the stopwatch, and this is also the stop clock. You can either be given this. So learners, very important to know them. Then the second a factor that is used in the measurement, especially for energy changes or enthalpy changes in the laboratory, is temperature. The measurement of temperature, we can use the equipment used in the measurement of temperature is the thermometer. There are 2 types of thermometer, the manual one and the digital thermometer. Even though the digital thermometer, this is the digital thermometer, it is more accurate. It's more accurate than this one. This one, you read by the mercury level. You read the mercury level in this thermometer here. As we go, I will show you how to read the mercury level in a thermometer. Because in your exams, you could be given different thermometers to read, especially these. You could be given different thermometers to read the different temperatures there. And you are expected to read them very well. So reading the thermometer is very, very important. The mercury level, you need to know how to read the mercury level. As we proceed, I will show you in the next page how you can read this. But remember, the units of temperature are degrees Celsius. The units for temperature are degree Celsius. It takes us to the next factor, which is mass. The next factor is mass. Mass is a this is a factor, is a measurement of weight. You can use to measure the weight of something. You, especially in the laboratory, you can measure the mass. You can measure the mass of a particular substance that you want to use in the laboratory for a reaction. The mass of maybe salt, the mass of anything you may want to use in the lab for any type of investigation. So mass is measured using a digital balance. This is the digital balance that is used for the measurement of mass, and it's about two decimal places. Even though the standard unit of mass is kilograms, but in our chemistry laboratory, what is required or what is usually used is grams. Remember, in the conversion, 1 kilogram is equals to 1,000 grams. It also takes us now to measurement of volumes. There are two types of volumes. Volumes for liquids and volume for gases. In your exams, you could be given, an experiment could be described to you, and you are asked, especially alternative to practicals in your exams, a practical exam, alternative to practical, mostly descriptive. You could be asked, or you could be given a description of a particular experiment or a particular investigation. And the question that follow could be, what apparatus was used for this? What apparatus was used for the measurement of volume? What apparatus was used for the measurement of temperature? What apparatus was used for the measurement of mass? In this case, there are many of these equipment that are used for the measurement of volume of liquids. We have the measuring cylinder, we have the pipettes, and we have the burettes. We also have beakers. In this case, it all depends on the accuracy. It all depends on the accuracy. For approximate volumes, where accuracy is not important, when you want a reaction or you want to carry out the investigation very fast, where accuracy is not very, very important, you can use a measuring cylinder. It gives you an approximate amount and you go faster. So where accuracy is not important, use a measuring cylinder. Measuring cylinders are in different scales. We have for 25 cm cube, we have for 50 cm cube, we have for 100 cm cube, and we also have for 250, even right to 400, we have the measuring cylinders. But where accuracy is very, very important, where you need to have an accurate volume, especially when it has to do with titration, you need pipettes and you also need burettes. Pipettes are graduated into, they are 10 cm cube, they are also 25 cm cube. Burettes we also have we have from 0 to 50 cm cube for burettes. So this is an example. Here we have these are good examples of measuring cylinders, where accuracy is not very, very important. But where accuracy is very, very important, an accurate value is required, we now use this one. We can now use we now use the pipettes, and we can also use the burettes. Especially burettes pipettes are very, very important. They are important in measuring let me say, a certain in titration. Let me say measuring maybe an exact volume of, let me say, of acid. Let me say 25 cm cube, or an exact volume of an alkali or a base. Let me say sodium hydroxide, 25 cm cube into a conical flask. Then the titram that we put into the burette, the burette run from 0 to 50 cm cube. This is the burette. This is the burette, and these are the cylinders, measuring cylinders. We can use measuring maybe for quick measurement, maybe distilled water, or any other measurement we want to do. But in this case, in the case of A, which is the measuring cylinder, accuracy is not required. It takes all to measurement of volume. There are also equipment that are used for the measurement of volume. We have the volumetric flask. The volumetric flask, again, is also used as a standard. Is used as a standard for the preparation of standard solutions. Is 100 is 1,000 cm cube, which is equivalent to 1 dm cube, or 1 liter. This is 1,000 cm cube, which is equivalent to 1 dm cube, or 1 liter. This is a conical flask, and this is a beaker. All these are also used for the measurement of volume. But when it comes to accuracy, we talked of the pipettes and the burettes. We move to measurement of gases. The measurement of gases. Well, in a chemical reaction where we need to determine the amount of gas that is being produced. Let's say for the decomposition of marble chips, when a marble chip that is calcium carbonate react with hydrochloric acid, we need to know how much of the carbon dioxide that is being released. We need to use a particular equipment for the measurement of the gas, and that equipment is a gas syringe. This is a gas syringe. This is a gas syringe. It is attached. The gas syringe is attached and put into the cork. The gas that is being released from the conical flask flows into it. Now, how do you read it? The gas syringe is graduated. You can see here it is graduated. It is graduated. Now, as the gas enters into the gas syringe, it pushes it and you see the level of the gas. So you can read it directly from there. Now, another equipment that can be used for the measurement of gas in the laboratory is an inverted graduated cylinder. We can use the same graduated cylinder we used up here. This is the same graduated cylinder we use here. This same graduated cylinder we used up here, which is this one. We can use it. This is this one here. We can use it and invert it and connect from the reaction beaker into it. For example, here you say this one here. We connect it here, and the gas, where we invert it and put it into a beaker, the gas that is being produced is red up here. The more the gas pushes the volume of water in the inverted graduated cylinder down. So this is an example of a graduated cylinder which is inverted. An inverted graduated cylinder. This is it here. It can be used in the measurement of gas when inverted. Now, we can summarizingly say that the laboratory equipment used for measurement are: 1, we have the stopwatch or a stop clock that is used for the measurement of time. We have a thermometer that is used for the measurement of temperature. We have a digital balance that is used for the measurement of mass. For the measurement of volume, both volumes of gases and the liquid, we have beaker, we have burette for accuracy, we have pipette for accuracy, we have measuring cylinder, and we have the gas syringe for the measurement of gas. Now, it drives us to the measurement of measurements that are done in quantitative analysis. Quantitative analysis, volume measurement in quantitative analysis. I am talking of titration. Titration, this is one of the methods we use to measure the accurate volume that is used in the accurate volume of the titrant that will react with the analyte. So in this case, this is a clear structure. This is a clear diagram of what happens during titration. During a titration experiment, you will need a measuring cylinder. You will need a conical flask especially for acid-base titration. You will need a conical flask to put in your acid there and the indicator. You will need a white paper or white tile. A white tile or a white paper. You will also need a measuring cylinder to measure for fast measurement of volume of liquids. You will need a burette stand. You will need a burette stand. You will also need a burette to put in the sodium hydroxide in it. You will need a pipette to measure the acid in it, accurate volume of the acid. In this case, how do you get your readings? How readings are done? How to read your burette? Remember, I told you there are two types of reading: how to read a thermometer and how to read liquid solution. Now, reading a thermometer, as I told you the other time, we have that is convex. In a thermometer, the line that you read should be on the mercury level. The meniscus should be below the line. The meniscus should be below the line for you to make the reading in a thermometer. But in the case where we are reading a burette, with a solution. Now, what happened is that this is what we call a concave meniscus. The meniscus must sit on the line you read. The meniscus must sit on the line you read. So, for instance, here, this is a burette. This is a burette here. In order to read this burette here, you have to read from where the meniscus ends. Where the meniscus ends, that is where you read. The meniscus must sit on a line, and where it is sitting on that line, that is where you take your reading. For instance, in this case, it is 22.30 cm cube. Let's move on how the titration is done. Now, after measuring the acid into the conical flask, we added an indicator using a pipette. We added a dropping pipette. Now what happens? We now titrated it with the standard sodium hydroxide solution. Now we have taken our initial burette reading. Let me say 50 cm cube. Now we need to read the amount, the volume of water, we need to read the volume of the sodium hydroxide that has been used in the reaction to react with the acid. This is the final Buret reading, where we stopped our reaction when we had our endpoint. You need to read this. You need to read it very well, as I've explained how to read the level of the volume in burette in a burette. So when you read this, this is how you present your results. In some cases, learners, you could be asked to construct a table and present the results. This is how you construct the table. You need to construct a result table like this one. You have the initial Buret reading, the final Buret reading, the tetra, the rough titration, the accurate titration 1, 2, and 3, depending the one you have been given. Your recording must be in this order, so that at the end, our initial Buret reading was 50 cm cube. The final Buret reading that we had up here, let me say up here, was 15 cm cube. And in that case, the volume of the sodium hydroxide, that have been used was 35 cm cube. This is how you record it. Now, we want to make a review of the common laboratory equipment and their uses. This is very, very important because learners, you could be given in your alternative to practical. The examiner can describe a particular investigation and ask you to list the apparatus that are used for that measurement. So if you don't know the different equipment that are used for different purposes, it will be difficult for you to answer such a question. So it is obligatory for learners to know about the common laboratory equipment and their uses. We now go to them. The first one is a beaker. This is a beaker with a glass rod. The glass rod is used to ensure that the solid dissolves in the solvent. This is a dropping pipette. The dropping pipette is used to take little liquid, say an indicator. This is a gas syringe, which we just discussed, used in the accurate measurement for gases. Now, this is a clamp and a burette. The clamp is used to hold the clamp, and the burette stamp is used to hold the burette. We have a graduated cylinder, which is for quick measurement of volume. This is a Petri dish. This is a torque that you can use in holding any glassware like the beaker. We have a tripod here. We have a tripod. A tripod and the gaze. We use them when we want to heat any solution using a Bunsen burner. We place the gaze on the tripod. And place the flask containing the solution for heating on it. The Bunsen burner is there to generate energy that is required for the heating. We have a test tube rack. This is a test tube rack. We can stand test tube there. We can stand test tube, open test tube. We can stand test tube with stoppers. We can even stand funnels there. This is an evaporating dish. An evaporating dish is another equipment that is used to heat a solution. Let me say a solution of sodium, a solution containing water and a solution of salt containing salt and water. A solution containing salt and water, and we want to crystallize. We want to crystallize it to evaporate the water, so that we have our crystals of the salt. We use an evaporating dish. The crucible is there. Wherever we have the crucible, or we use our mortar, any of them, the crucible or the mortar, we can use then the pestle. We can use this to crush lumps or big salts into powder before dissolving them. Now, it moves on now to these other ones. We still have the beaker here, as I said. We have the test tubes, I've explained to you. We have the test tube holder when we are heating it. We have the clear triangle. The clear triangle is used to place on a Bunsen burner before putting the clear on it. We have a dropping pipette used to take little volumes of liquid, let me say indicators, and put it into a conical flower when we are doing titration. We have a burette clamp. The burette clamp is here to hold burettes. We can also hold other glassware there. We have an evaporating dish, as I told you. This is to evaporate water in a solution of salt and water. You can evaporate the water, and the salt is left behind for our crystals. So generally, it is used for evaporating water or for the process of crystallization. Then, then the funnel. We have not talked about the funnel. The funnel is also there for filtration purpose. It is used for the purpose of filtration. So learners, once more, this is very, very important for you to know the names of the different equipment that are used in the laboratory for investigation. So thank you for watching. Please like, share, and subscribe for more YouTube practical lessons. Thank you.